I wanted to give you guys one example of sort of a non-standard trig integral. So when I say non-standard, I mean that a nice u substitution doesn't work out. The idea with all of these is basically to do some sort of algebra to change the way the integrand looks. In my example, I have the square root of 1 minus cosine 6t, and I need the antiderivative here. So what I'm going to do is artificially make that 1 minus cosine of 6t into a fraction. And then I'm going to multiply the top and bottom of this fraction by 1 plus cosine of 6t. Okay, now this may seem counterintuitive because like this looks worse than what we started with, right? And if you're thinking that, you are not wrong. However, this trick works a lot because we have the Pythagorean identities that when we have cosine squared, we can do something with that. Okay, so I'm foiling out the top. We end up with 1 minus cosine squared of 6t over 1 plus cosine of 6t. And then 1 minus cosine squared of 6t is sine squared of 6t. And I know the square root of sine squared is just sine. So we have the integral of sine 6t divided by the square root of 1 plus cosine of 6t dt. Now a nice u substitution will work. We can let u be 1 plus cosine of 6t, then du is negative 6 sine of 6t dt, or in other words, negative 1/6 du is equal to sine of 6t dt. So the integral we have is equivalent to the integral of 1 over the square root of u, and the sine 6t dt gives us a negative 1/6 du. Or in other words, negative 1/6 times the integral of u to the negative 1/2 du. And now we can use the power rule. We have negative 1/6 times u to the 1/2 multiplied by 2 plus c, which is negative 1/3, and I'm substituting u. U is 1 plus cosine of 6t. So we have negative 1/3 times the square root of 1 plus cosine 6t plus c.